Welcome, everybody. Nice to have you here. We're excited to be speaking about an incredible solution today. As you all know, the Smart Building Collective Smart Building Certification is founded in science, refined by practice, and constantly optimized by our network of experts. And one of those expert companies that's part of the collective ecosystem is MeteoViva. And we're really excited today to join with Peter Crijns from MeteoViva, where we're going to go through their recently achieved solution certification to talk all about how this solution maps up against the SBC framework and how they are driving impact in such an important area of smart building, indoor climate and energy optimization of everything. And what we're seeing a lot of in the smart building space when it comes to business cases, value propositions, and making sure that the smart building pays for itself, energy optimization is one of those areas that has incredible potential to actually fund your entire smart building program in a lot of ways. And a lot of companies are doing that. They start with energy and then they expand to all the other functionalities and all the other things that you can do with smart buildings. So we're excited to dive into it today with Peter. But first, to give you a refresher on the SBC framework and how it is driving value and impact for the smart buildings that we're certifying. The framework is built up of 5 core modules and then is all brought together with integrative design and connectivity and infrastructure. Without connectivity and infrastructure, the entire thing falls over. But integrative design is saying, how can we, with the least amount of technology, maximize the value in all of these different areas? So building usage is how well do you have control over how your asset is being utilized, thinking about occupancy management, amenity usage, these types of things. But in your energy and in your lighting and these types of things, you can definitely see how the asset is being used. So we'll be talking about that today. Building performance is all about your sustainability aspects, thinking about energy consumption, water, all of the things that make a building perform optimally or not. And within the building performance module, we're talking about HVAC systems and BMS systems and how to optimize these things. So this is going to be a really interesting point to talk about today with MeteoViva. Building environment is really the health and well-being of the environment. How do you support indoor air quality, sound, light, making sure that the environment is optimal for human performance. That's a critical aspect to a smart building and a critical value driver. Safety and security is both physical and digital. It's about keeping people safe in the space, but it's also about keeping data safe. So we need to talk about cybersecurity. How are we making sure that the data that we're using constantly is secure? And then user behavior and collaboration is how do we allow people to interact with each other, but also interact with the building and make sure that the building is always being optimally driven for them. And what we do is we benchmark buildings on a total level that looks at all of these things comprehensively, but we also benchmark on sub-levels. So you will see some buildings that do very, very well in building performance and safety and security and have opportunities and areas for improvement in other areas. So this allows the unique story of the building because out of all the buildings we've certified, we haven't seen a single one that is the same. It allows the uniqueness of buildings to emerge. And I think that that's critically important where we are in smart buildings. Without further ado, I'm going to bring Peter up to the stage and we're going to dive into his incredible solution. Hi, Peter.
Good afternoon.
How are you?
I'm very good. It's
nice.
Yeah.
Good. So
it's what we want to do.
What we want to do is start with a little bit of background Where does MeteoViva come from? How long has it been around? How big are you guys, and what's going on?
It's started in, I think, around end of 2007, 2008, and our technology or our vision hasn't changed, but the market has changed in that meantime. So we still have our approach because we are a spin-off of a German university. That's why also our headquarters is in Germany. And the basis was the thermodynamics of materials used in buildings, and how to combine that with data, with building management systems, and to control it, and then from there on to optimize the usage of the building, and give that unique perspective on how to effectively run the installations of the building. And what I said, our vision and our way of working hasn't changed, but the market has changed. Energy consumption and energy prices have increased in importance, and people want a good comfort, but not wasting any energy, and that's what we do.
Yeah, critically important. So in most basic terms, what does your solution do?
What we do is we build a simulation model like a digital twin, but therein we incorporate all the thermal dynamics of the building. So how will the building as a whole or as a zone react on changes or energy changes outside, so from weather changes, but also of the usage internal. When do people come in? What kind of equipment do they use? And also what kind of HVAC systems or way of bringing heating and cooling into the building are available, and how quick and how do they react. And we combine that all in a we call the MeteoViva model, where we put in all the variables. And what we do with that is on a quarterly base. So every 15 minutes we calculate per zone the expected amount of energy needed to have a stable indoor climate, but not waste energy, because the sun will come by and then it will go up and you have to cool it down. And that volatile indoor climate or indoor temperature we try to prevent with a proactive controlling of the BMS. And with that in mind, you have a more stable indoor climate, less energy consumption, and that's a solution that everyone wants. And because the way that we work, we build up the building in logical climate zones, it doesn't matter what the size of the building is. If it's 10,000 square meters or 150,000 square meters, it only means that the model is bigger and more complex, but those models, they are running in a data center, in two different data centers in Germany. So it's you don't have the server capacity needed in the building, and it's for us, the sky is the limit in size of buildings.
Yeah,
literally.
And you all are experts more in the larger buildings. I think that's important for the audience to be aware of, that your guys' focus is very much bigger buildings, and so that's fantastic. And you guys have been around since 2007, founded in Germany. And how's it going?
It's going because we are we've been there for a while, so the technology is a proven technology, and it's also now accepted with big real estate companies that have big portfolios. So we do, for instance, a global portfolio implementation for Deka Immobilien, and yeah, we proved our added value in a few buildings of them in a pilot, and then we said, okay, let's do more buildings together. And the same we also do for different portfolio customers.
That's fantastic. And primarily, so how many employees and which geographies are you in at the moment?
At the moment, we do buildings from Seattle to New Zealand.
Oh, wow.
But
Which
we have.
direction? No, I'm just kidding.
Yeah, true. No, it's but our headquarters is in Germany, and our main workforce is also in Germany. So most of our engineers, the R&D development, and the IT is all in Germany. And I think altogether it's 50 people.
Okay.
We have a subsidiary in the United States, one in Switzerland, and I'm responsible for the Benelux.
Okay. That's pretty good growth. And when we talk about there's a ton of questions, but focusing on energy as the first impact area that you guys are working on, what kind of energy consumption or savings are you guys kind of proving to be able to achieve?
On average, we save about 20% of the energy consumption of the building installations, and that varies between 15% in a very well controlled building, and it goes up to 40-50% in buildings where there's a lot of low-hanging fruit that you could also, by looking a bit more critical on the installation settings, could also save. So it's always around 20, say an average 20% that we can certainly save. And a very beautiful example is the R&D building of Souter. Souter is a BMS company, and we have a strategic partnership with them. And we did their building where they developed their entire products in Freiburg. And there we did 1 year long, we did an alternating operation. So the 1 week of MeteoViva was in the lead, and the other week Souter was in the lead. And even in that building, we saved between 16 and 17%, I think.
Wow.
Just by,
That's incredible. And would you say that savings then pays for the solution, or does the solution, is it expensive in comparison to that savings?
It is, comparison to the savings, it's actually always free because it pays for itself.
Yeah. Very nice. Very nice. And that case that you just talked about with Souter is a BMS system, right?
Yeah.
And so often people are saying, I have a BMS system. Why do I need another system to control the BMS system, right? Because building management system should manage the building. So, for those that are struggling with that discussion, why would you need a tool like this to manage the BMS? And I'd love to hear also Souter's view on it, because that's they're a BMS provider. So it's interesting that they are working with you guys as well.
I think because we only make a simulation and we make an expectation how the installations of the building will operate, and we expect the HVAC systems in the building to do what we tell them to do. So we don't go into the internal controls of HVAC systems, but we only give a process we activate the process and we give a set point of the temperature, for instance, what we expect to be there. But how it creates that temperature, that's up to the internal controls of the system, and that's a BMS. And so we are also depending on reliable systems in the building, and therefore that's also for every building important that the installations do what is expected of them.
Yeah.
And therefore you need a BMS in a building. But we because we look forward and we know how the building will react, and that's something that the BMS, like Sauter as Siemens, because with both we have a strategic partnership, say, okay, what you do, is something that we will not be able to develop, and you have proven yourself in big buildings to be efficient in that. So we trust you and we want you to, in essence, operate their BMS.
Okay.
And on a proactive way. But we still have, for our system to work completely, we are dependent on the systems in the building.
Yeah.
And that they also work correctly. And we can pinpoint failures in the system, because when we expect some energy to go into a zone and the energy comes in all other zones except of that one, then you know where something is wrong. So that's also something, because we know how the building will react, and if it for which reason doesn't do what we think it would do, then we can very easily pinpoint the flaws or what is broken. So that's also for a building owner, again, better to know how his building is reacting and where stuff goes wrong, if it goes wrong.
Yeah, I think we see the certification program similar, right? I think what's so important is to realize that smart buildings are not simple. They're not just, easy to run. They're complex ecosystems. They're complex challenges, and those checks and balances are very, very healthy for a smart building. And I think what we're hearing from you is that MeteoViva is very much a check and balance on the infrastructure of a building, which I think is really interesting, because if it's working, you guys will know. If it's not working, you will know.
Yeah.
Yeah.
And then it's better to say, okay, we know that there is something wrong. The temperature doesn't reach that zone, so that you can also inform the tenant or the user of that zone from, okay, we know that it will be a bit colder, but sorry, we are working on it. We know where the problem is, but we know where to look, instead of waiting to that they start complaining.
Yeah. You were just recently at the Smart Building Show in Nieuwegein, and you had a panel discussion with Sauter. What was that? Can you share that analogy that you guys made in that discussion about the race car?
Yeah, it's Sauter, they call it, it's Sauter Autopilot, because they are very good in running the installations and knowing how installations should function and function efficiently, so that the heat pumps are not pendling or doing strange things. But when it comes to controlling the car, like the BMS, they prefer to have a Max Verstappen driving it so that they can win the race instead of driving it themselves. That was his his way of telling it, but it's
the BMS is the car of the building, and anybody can drive it in a way. But why, you can also have an expert driver driving it, and that's kind of how the MeteoViva platform is seen by Sauter and yourself. That's I think that's a really healthy way for people to understand how the BMS system is meant and how it is supposed to deliver on its promise. And where it ends and where it begins is a really important piece to take on board when you're building your smart building. And then
And
thinking
that's
about,
also, and
yeah.
then I have to mention we do work good together with Souter, but we are completely manufacturer independent. So we have buildings with prefab BMS systems, with Schneider systems, Keywork and Peter, and also it's for us. It's we can talk every BMS language or dialect that there is.
Mm-hmm.
So that's also for those portfolio customers of ours that have a lot of buildings. Most of the buildings they didn't develop themselves, but they bought the buildings. So they have to they have a lot of different types and variances of BMSs, and so it's also important for them to know that we can connect to every building.
Yeah.
And
Yeah. And
that's
I think what I want to do is I want to go through the SBC framework a little bit, but then at the end, I think it's important to talk about your guys' auditing process and your assessment process, because I think that's also actually hugely useful for buildings without even MeteoViva, just to understand how do you kind of capture what's going on in your building. Because like I told you in our pre-call, when a building changes ownership 3 times, by the time it's changed ownership 3 times, it's lost 96% of its documentation. And that's incredibly challenging for a new owner or a new user of a building to understand how this smart building infrastructure works. And that's something that we, from the Smart Building Collective certification, really believe is part of our role, is helping people understand what is in this building and what can it be used for, and how can you add and get more value out of your asset from these smart technologies. What we'll do now is kind of go through the different framework pieces, and we'll start with building usage. How does your solution help an asset owner or a facility manager or a user of the building understand how the asset is being utilized? How do you guys capture that piece of information, right? Because I'm sure you guys base your modeling on occupancy, on how it's actually being used. Can you walk us a little bit through how you guys tackle that piece?
Yeah, perhaps it's also then good to say what I just mentioned briefly, that we divide the building into logical climate zones. Those are dependent on which switches we can influence and can turn, and then you can very on a very flexible basis use your building. So you can say, okay, one zone needs to work 24/7, for instance, and then we take that zone and that usage pattern for that zone for 24/7, and the rest of the building not. So yes, some system will run them 24/7 because they have influence on that zone, but all the other systems not. And that can be fine-tuned very easily by the users of the building, but it can be incorporated to booking systems or whatever source of data is available or can be made available to us about the usage of the zones. We can incorporate it, and then because we calculate every day again for the next 3 days in advance, we will take the new data and optimize with that uses with those patterns and internal loads in those zones. So yeah, if the data is available, we do not capture the data ourselves. We can see, for instance, if you have a building that is run 24/7, and it's also it runs 24/7. We have a building now in monitoring, and you see that people come in starting at 6 in the morning up until 12 at night, because then you see that the HVAC system runs almost at full speed, and then it goes down a lot. So in those hours between midnight and 6, I would say that there are not a lot of people in the building. And that's stuff that we can then optimize with the data that we see. But if there's more data available, and there are a lot of solutions and smart solutions in a smart building that provide those data, we can easily incorporate those.
But you don't
And
necessarily need to. You can also just do it based on scheduling.
we can do it based on scheduling and okay, what times do we want to have, or what are the basic times, and then the user or the tenant can adjust it themselves if they want to.
And there's massive value drivers for having proper occupancy management, for spaces, meeting rooms, just for shared spaces, these types of things. From the buildings that you guys are working on, how many of them would you say have that occupancy data? And is that occupancy data actually really useful for what you guys are doing, or is it kind of a nice to have?
I think now it's often nice to have in some buildings that are where the company is too big for the building, and space and workstations are scarce. Then it's very good and very they have an added value in that. That people know where they can find a place to work easily and not have to walk around the building first for half an hour to find a spot to work. But in a lot of buildings, I still see a lot of workspace that people are less, not flexible, but people are creatures of habit and go to the same space often.
Yeah. The a tenant is too small for the building, right? It's also very useful to have that occupancy data to help them understand where they should be putting people and where they can close some zones off, hopefully.
But that's something, because it's that's the other side of the occupancy data. If you don't use the space, then why should you have the space?
Yeah, 100%, 100%. And so, okay, so that's really usage perspective. You guys can either do that manually based on kind of their assessment, or you
Historic data, and
or integrate it with occupancy data, which hopefully is being used for other things as well. And do you guys integrate to systems that are using like workplace management systems and occupancy management type systems? Do you guys integrate with those, or do you kind of keep it separate?
we get the data from them that we need. So we build an API or get the data incorporated into our system. But we are not integrated yet in other systems. So, for instance, I know with Souter they want to do that, but that's still in the developments and in the future. So it's still two systems.
Well, I think it's also, I think we're learning a lot as smart building experts. Is that it used to be we want everything on a single pane of glass. Everything needs to be integrated. Everything needs to be in one tool, which comes with its fair share of headaches, I think. But now I think there is logic to kind of having things be in certain buckets, with certain stakeholders having certain access to different tools. And I think MeteoViva is one of those that, you have your analysis on your energy and all of your parameters that need to go into that analysis, and that's probably pretty good.
But Yeah, but that's also then, for instance, for a maintenance company, it's very convenient for them to have both systems working side by side, so they can see what set point we ask of the HVAC system, and then also be able not to only to see that the set point at the moment, because in the BMS they can see the set point what it was, but we can have the trend data, yeah, for when we save all the data on a 15-minute basis. And yeah, that's something very valuable, because if at one moment it works and, for instance, at night it doesn't work, or then there's something wrong, but then you can analyze the functionality of the BMS on that side. Okay, why does it do? Yeah, why is it working in this situation? It does, and in this situation it doesn't. What can be wrong?
Yeah.
And yeah,
So for how an asset is performing or being used, do you also see in your platform kind of lighting and air quality and these types of things that would give indication of how a space is being used or not?
um, we because our zones are bigger than single rooms.
Mm-hmm.
Um, if the data is available, for instance, if we can incorporate the CO2 levels, that is if they are measured in the zone, we can incorporate them. In essence, we can incorporate all data that is available, but
Yeah.
we
Okay.
always say, yeah, you have big data, you have smart data.
Mm-hmm.
Not all data that is available in a smart building is also
Needed
uh,
for this.
needed, or for us, it's not all essential.
Yeah. Sorry. Um, So let's move to building performance then. So building performance is about energy consumption, water, sound, or how well the asset is actually performing against the promise. When it comes to MeteoViva, it's energy. That's really where you guys are focusing your attention.
True.
True.
We yeah, that's what I said in our simulation model. Our goal is to increase the comfort in mainly office buildings. We do also do other buildings like airports, or we have some maintenance facilities of the Deutsche Bahn, but mainly big office buildings. And yeah, to increase the comfort levels in the building, but at the same time reduce the energy consumption of that building, because it's always the most easy way to get rid of complaints is, yeah, turning on the heat more in the winter and turning on the cooling more
Yeah.
in the summer, and then the complaints go away, but your energy consumption starts skyrocketing. Or leaving all the installations running 24/7, because then you know that the building will remain at this temperature, and that's, yeah, a big waste of energy.
Yeah.
And
So you
if
guys are
you look at
playing
it,
between, yeah, the building performance and building environment. You're finding the correct equilibrium between those two.
yeah, and because we know how the building reacts and will react, and what kind of energy is stored into the building, uh, and how quickly it can go back to the level that you want, and it's not needed to have everything running 24/7.
Yeah. Yeah.
And uh, I sometimes we see buildings that are running 24/7, but I'm glad that most buildings nowadays uh, have already seen those low-hanging fruits to yeah, reduce those unnecessary energy consumption.
Yeah.
But still, there's a lot of yeah, energy to be saved additionally on top
And
of that.
do you does MeteoViva get involved in in grid distribution, and when you pull data or pull energy off of the grid from certain types, like if you talk about renewables versus, other energy sources?
We can incorporate energy pricing and demand into the model. I know that's a big thing in the United States, because there it is in Holland. It's quite the same comparable price for energy during the day, but there it is. You have slots that are more expensive than others, and then you want to have more energy usage or consumption in the when the prices are lower than when they are higher. So yes, we can incorporate that, and it's also what we also have is a MeteoViva campus solution. So then if you have more buildings in one campus area, and they are connected, for instance, with on one heating and cooling circuit, then you can also, if you optimize all the buildings individually, you also know what energy consumption is expected in the next coming 20 or 72 hours or 3 days, and then you can also optimize the cooling and heating exchange between the buildings like that. And that's a very good step in the future. We have one now at Düsseldorf Airport, but it's the infrastructure needs to be there to also have the heat exchange so that we can optimize that one.
So right now, it's not necessarily automatic for when you pull energy based on pricing, but by correlating it, at least analyze it, and you can start to make decisions based on that analysis.
Yeah, and again, if the data is available and if the wish is there, we can incorporate it. But then the focus will then be on the cost reduction and not on the energy usage reduction, and that's sometimes when energy is cheap or then it's sometimes better to use more energy, or because otherwise the infrastructure is overloaded. And we can incorporate those variables as well if the data is available and the wish of the customer is there. So and that's the unique thing of our model, because it's a simulation model based on physics of the building and the other data, and because we know how the building will react, we can also calculate what it will do if we start cooling or heating sooner with the lower energy prices and still be able to have the desired indoor climate.
Yeah, really nice. Okay, so let's move a little bit to data and cybersecurity, and how do you guys keep this aspect of a building safe? Do you guys, how do you guys do that?
How we do it, I always, because we do get that question a lot from, for instance, financial institutions, and they want to be safe, and I always say, what's the biggest financial institution in Europe? That's the European Central Bank, and that's one of our customers.
Yeah, okay.
We have been in those towers since the beginning that they have been delivered or built, and everything, our entire system is redundant, it's encrypted, it's certified, it's encrypted to the highest level. So it's how exactly it works, I don't know, but I do have my security experts that I then put down in a room with the security experts of the customers, and after half an hour they are both always happy. And it is it has been tested and pen tested and always succeeded. So
Well, I think that's one of those aspects of, right, when you want everything under one single pane, everything integrated with each other. That's where that security complexity comes from, right? Because you can have
yeah,
vulnerabilities throughout your whole infrastructure. And I think if you look at MeteoViva, it's quite a standalone system in comparison to the whole infrastructure. If that makes sense. I mean, you're integrated to the BMS. Um, you're taking data from different areas, but I imagine that supports the security.
yeah, but then it will be a bit technical. But if we integrate or connect to a BMS, we have an interface needs to be built, but we select the data points that we want to have, and which we want to control, and which we want to log, and only those data points will be extracted from the BMS. And then it is also that we have a serial connection, so it's not Ethernet directly into the building. So it's always disconnected and then over another interface with another protocol to our box and then out to our data center. So it has some steps to go, but there's never a direct link from our data center into the system of the building.
Okay.
And that's yeah. Then that security is then also covered, because that's often something that our customers want.
Yeah. So if we move to the next one, which is kind of user behavior and collaboration, how do you guys account for users in the building of changing the systems or saying it's cold, or how do you guys capture that data?
That's people still have the ability to add or subtract, say 3 or 2 degrees locally. So in the zone, one can say, okay, I want to have it a little bit hotter. I put +3, and 2 rooms down the road, someone says, okay, I want to have a bit cooler than -3. But we provide the energy needed to that zone, and then it's the subdivision of the energy in the zone is done by the local controls, and those are remain for the the users to adapt and change however they want. But because we can also have a lot of data on what the temperature was and measured, then it's also for property managers, if there are a lot of complaints, then we can very easily look back how the zone was behaving, and there's a lot of data available. So you can have a very good discussion based on data, and that's the fun part of data. It often doesn't lie. If the
Yeah,
sensor is broken and there's a different output, but then it's
that's a different problem. Yeah,
that's a different problem.
yeah. Nice. We wanted to. I'm gonna share a slide or two from you. Let's start with this one. Can you walk people through a little bit how you get to the implementation, and how do you guys capture what's really going on with the building?
So what we do is we have 3 actual phases and 1 pre-analysis or a small estimation if the building is feasible. So it's a quick feasibility study based on type of BMS, energy consumption, the size of the building, and with then we can say, okay, it could be a good building to do. It could have a positive business case, and but to be sure of that, let's do a feasibility study. So that's phase 2, and in that study we will analyze the entire building, the entire HVAC systems, what can be done, what can be influenced, what was the consumption, energy consumption, how does it compare uh, to other buildings, but also is what are the possibilities of and the energy saving possibility that are in the building. So it's a very thorough analysis that is done, and it's also immediately the project plan for implementing MeteoViva. So the entire concept, which points do we want to influence, which data do we want to have from the building. Everyone in the building is also incorporated in that phase. So the property manager, the maintenance company, the BMS company, everyone is involved and needs to give their information.
Okay.
And
when you do that feasibility study, you're pretty certain that this project is going forward, or is that to see if you can go forward with the project?
That is, if we do that study, then in the report, there's a price for the implementation and also for the operation later on.
Okay.
That's a fixed price, and also the savings that are calculated in the feasibility studies, we can guarantee those.
Oh, wow. Okay. So but it's not a guarantee that the project's going to go forward then at that point.
Eventually, there's still the decision of the owner of the property if he wants to have the project done.
Mm-hmm.
So yeah, but then it is. But then he knows, okay, what will it cost me? What are the benefits? What's the added value? What's the savings that are guaranteed? And what's the payback time also?
And is the feasibility study, is it useful in itself?
It's a lot of issues in the building because we look at it from a different perspective as an outside engineers who look at the building, and then sometimes issues in the building, we notice them that perhaps were not noticed or not brought to the attention of the owner. So that can also be helpful, but for us it's a way, because without that study we don't know how we should set up the our MeteoViva model and concept. And often with portfolio customers, it's when we do it, the quick analysis based on the square footage and then the energy consumption, then they say, okay, do a feasibility study and direct after that go into the setup, because we want to have it in our entire portfolio, but still do the feasibility study that we know what it will cost, what it will bring, and what is needed. And so therefore
you do that per building.
We do it, and it is it still is a go-no-go moment. Mm-hmm. Because if in the feasibility study there's a negative business case, then the owner still can say no, we don't do it. But it's it's a quite elaborate analysis that is.
Well, and I think that's what's so refreshing about it actually, is that it takes the complexity of the smart building and the seriousness of it and breaks it down in a meaningful process that will get you to heightened savings. But it's what I like about it is it's not this light sales that says it's easy, we just plug it in and we're done. I think there's a very much a human aspect to this, and making sure that stakeholders are aligned, that make sure that you're getting the team in place, that you're really assessing the current situation before making the next step. I think that's appreciated.
And it's also good to know that when we do implement it, it's the savings start immediately when we go live.
Yeah.
So our model is also, it has a continuous improvement in it. So it monitors itself and it improves the model, but the model is when it starts, it's starting to save energy immediately. And that's also when the setup is finished and we are in operations. That's it's been monitored 24/7, and everything is optimized every day again, and sometimes also multiple times a day. When, for instance, the weather, if the sun comes through earlier because the clouds are the wind is quicker and the clouds are quicker, then sometimes it's you have to calculate again.
Yeah. Brilliant. You know, I think there's a lot here. I think you've definitely helped the audience understand more about what MeteoViva is doing, and I think it's fantastic to have you guys certified and in the ecosystem, and to be learning from each other, and really moving the needle when it comes to energy consumption. So really, congratulations on both those things, and nice work. And thank you so much for sharing everything about how MeteoViva works.
Thank you for the opportunity to tell more about our system, and also for combining the different parts of a smart building, because MeteoViva is only one aspect of what makes a building smart, and there's a lot of different great companies in the collective that combined can provide a very good solution of a smart building.
100%,
And
100%.
those combinations are valuable, because I always say, you have to do what you're the best at and focus on that. But the combination is, one and one can be three in that instance.
And what we're promoting more and more is that focus on energy consumption, get the savings from that energy consumption, and use that money to invest in the rest of your smart building program. So it's everybody is required to collectively work together. You know, they need the savings from a company like MeteoViva in order to do the other things that they want to do.
Yeah, and it's also one thing. It's good for it saves money, but it's also additional added value. It's not only the way of saving money, but the comfort, the increasing comfort, and everything else that you get back from it. It's also value added. That's not always, because people always look at what's the bottom line
100%.
of, but
Doing it in balance. Yeah, always.
That's true.
Thank you so much, Peter.
You're welcome. Thank you.
We'll speak to you soon, and good luck.